Today on Blender Bitstream, I'm bringing real NASA data into Blender. I'll be using the free open source image editor GIMP to prep the images before I start building the scene. All the links you need are in the description. Now I'll start by opening the first link, which takes me to the Goddard Space Flight Center site. Here at the top there's a link to MIT where I can download the tiles. These were made using laser scans from the LRO. I'll need the JP2s first, and the 512s have more detail, so I'm using one of those. JP2 keeps the files small, but converting them for Blender makes them grow, so make sure you've got a few gigabytes free. These tiles don't include albedo because they were scanned with the laser altimeter. We need to grab albedo from another instrument and line it up with the JP2 tile in GIMP. For the base color, I'll download the LROC color EXR. It's about 1 gigabyte. I'm also downloading the LROC height map so I can use it to line up the JP2 tile in GIMP with the LROC color once I locate the matching area. Now in GIMP I'll load the JP2 file. I want to convert the JP2 into a 16-bit grayscale PNG so Blender reads the height correctly, so I'll set the export pixel format to 16 BPC gray. I'll also turn compression down to 0 and uncheck all metadata. Now the JP2 has been converted, I'll open the LROC color EXR and the LDEM 64 height TIFF. GIMP has a problem loading this TIFF, but that's fine because we're only using it as a reference. We can correct its levels by eye so there's enough visual data in the similar range to use as a comparison guide. To make the correction, I go to the Colors menu and choose Levels. I'll adjust the left and right stops in the Levels panel, making the left stop 55 and the right stop 60. This will make the full scan height map look similar to the JP2 so I can easily compare them. Once the levels are corrected, I'll press Ctrl A to select everything, then copy it through the edit menu. Then I'll paste it into the LROC color image. The images are different sizes, so with the layer still selected, I'll go into the layer menu and choose Scale Layer, setting it to 27360 by 13680 to match the color map. Now that the color map and height map are processed and scaled 1:1, I can go back to the converted JP2 scan and select all and copy it. To start, I scale the pasted JP2 to roughly the same size as the LDEM using Scale Layer in the Layer menu. 4000 by 2667 is a good starting point. I've already found the matching area by looking for features like double impact craters. From there, I uniformly scale the JP2 until it replaces the LDEM version. Using the transparency slider helps confirm the alignment. It takes time, but it gives you accurate base color placement once both images line up. Now that the two are aligned, I know exactly which part of the LROC color map I need to copy so I can finally build the color map for the converted JP2 scan. I'll unhide everything except for the LROC color layer, and with the area still selected, I'll copy that section of the LROC color map. If you need to reselect it, just right-click the layer and choose Alpha to Selection. Before I paste the LROC color into the converted JP2, I need to switch the image to color mode in the image menu under Mode. Once pasted, I'll scale up the layer to the image size, again using Scale Layer. Now that it's scaled up, I can export it as a 16-bit RGB PNG, again with compression set to 0 and no metadata. The materials are processed and ready for Blender, so I'll start a new scene and set up the render settings so I can render these big maps without too much hassle. The render settings for this are pretty lean, and if you want the exact setup I use, I recommend watching my short on render settings. Before I add any mesh, I'll increase the view range. You can do this by pressing N in the viewport, opening the view panel, and setting N to a higher value. I'm setting mine to 100,000. Next I'll add a plane mesh and set it to 4820 by 4545. Once the dimensions are set, I'll apply its scale. The image scale ratio is different, but once the curve of the moon is taken into account and the scan curve is applied to the plane, the surface ends up around this size. With the plane selected, I'll press backtick and choose View Selected to see the full plane. Now I want to subdivide the base mesh, so I'll go into Face Edit mode, right click, choose Subdivide, and then set iterations to 3. Then I'll add Shade Smooth. For the deformations to work without issues, I usually use an empty as the reference object, so I'll quickly add a plane axis empty and set its rotation to X minus 90 and Z 90. Now I'm ready to add the two maps I processed earlier. First I'll just set the view range for the shading workspace to 100,000 and then I'll center the view. Next I'll switch to world shading and set the background color to black to match the darkness of space. Back in object shading, I'll add a new material and name it. The roughness I'll set to 0.8 and the IOR I'll set to 1.1. Now in the material settings, I'll set the displacement to displacement only. I can now add the images for the base color and height map using the two processed PNGs. The height map should be set to non-color. The displacement node can now be added and plugged into the material output. I'm using world space, and the mid-level should be 0 with the scale set to 75. Now I'll plug the height map into the displacement height and color map into the base color. Back in the modeling workspace, I'll add a subdivision modifier, switch it to simple, and set the iterations to 5 for now. Now I'll add the first simple deform to emulate the scan range, setting it to 45 degrees on the z-axis using the empty as the origin. Next I'll duplicate the first deform and set it to 30 degrees on the x-axis. Now I'll quickly add a sunlight source and set its location and rotation. In the light settings, I'll set the strength to 2. Now to make sure the light reads properly, I'll set the look to very high contrast in color management. Next I'll set the viewport to rendered. Now that everything is ready to be rendered, I'll turn the subdivision modifier up to 10 so the full range of the height data can be seen. If you're worried that your rig might not like this, increase it one iteration at a time. Scaling the images down also helps on lower end specs. Hopefully this gives you a clean, reliable workflow for your lunar landscapes. If you'd like to support the channel, leave a like and subscribe for more Blender Bitstream. Thanks!